exponential logarithmic. I don't know if you're happy that we got the booklet, but we got the booklet. Disclaimer, you know what's going to happen, right? There will be some typos. If you can live with that, you'll be fine. I just didn't have the time to actually check everything again. I just put it together, slap it together, go. Okay. All right, let's go and explore exponential functions. So just so you know, going right up until the break, we're going to do exponential logarithmic, and then that's what we're doing now. Those are the two functions that you haven't seen yet. You haven't talked about them, but those are the two that we're gonna start with exponential, and then we're gonna talk about logarithmic. Right? Sounds like some kind of dance, right, or a song. Rhythmic, I don't know. But anyways, we're gonna explore these two, and then the last one before the break is gonna be sinusoidal. It's gonna be sine wave. It's gonna go up and down indefinitely, right? And then when we come back, it's gonna be all finances, investments, loans, stuff like that. So this unit will be about a week. And what's nice about this unit is it kind of piggybacks off of last unit, right? We're still dealing with functions. We're still using second trace a lot. We're still talking domain and range. All of that stays the same, okay? And at the very end, when we're done this, I've done it in the past where I fill up the whole board. We look at all functions, and we look at all the things that they do or do not have. So you kind of have a good overview of all these different functions that we've studied, okay? So here we go. We've covered polynomials degree 0, 1, 2, 3. In this section, we'll explore exponential logarithmic. Let's explore by creating a table of values. So a table of values, you've done that in grade 10, intro to applied and pre-cal. We didn't do it so much. I mean, basically when you're doing the fencing questions, you're making a table of values. When you're doing the profit question, that's a table of values, right? That is actually what you're doing, but in this way, we haven't done it. So I'm just going to take it easy. 0, 1, 2, 3, and 4. We like small numbers, okay? So if x is equal to 0, what is y going to be equal to? If we consider this equation, do you notice something interesting about this equation? Where is x? It's the exponent, right? It's different. We used to have them in line. Now x is all of a sudden is the variable, as it's actually the exponent, right? So let's figure that out. 0 is equal to 2 times 3 to the power of 0. That is really what's anything to the power of 0? Uno, right? And so 2 to the power of 3, 2 times 3 to the power of 0 is really 2 times 1, which is 2. That's very important, right? We're going to actually find something about that in a bit. Y is equal to 2 times 3 to the power of 1. Everybody knows that that is 6, right? Sure. Whatever you say, Mr. Pearson. 2 times 3, right, to the power of 2. That would really be 2 times 9, which is 18. Right? Another point that we found. Next, y is equal to 2 times 3 to the power of 3. Notice x is always my exponent. What's 3 to the power of 3? 27, right? Which is 54. And then next is y is equal to 2 times 3 to the power of 4, which is, break it down into 3 squared times 3 squared. 9 times 9, right? 81. That's 162. Okay? And let's see if we notice a pattern. Before we do the pattern, let's do the one for the next here. F of x is equal to 10 times 1/2 x. Let's do the same thing. 0, 1, 2, 3, 4. If f of 0, it's just a different way of writing it. 10 times 1/2 to the power of 0 is just 10 times 1. Even half to the power of 0 is 1? Yep. Anything to the power of 0 is 1. And that is 10. F of 1 is 10 times half to the power of 1, which is 10 times 1/2, which is 5, right? F of 2. Why does he speak Spanish every once in a while? Stop doing that. That's 10 times, what's 1/2? Half to the power of 2, that would be 1/4, right? Because you're really squaring both the numerator and denominator. And that is 2.5. F of 3, 10 times 1/2 to the power of 3. That's 10 times, what's 1/2 to the power of 3? 1 to the power of 3 is just 1. 2 to the power of 3 is 8, right? And that is 1.25. It's really 10 times 1 divided by 8, or 10 divided by 8, same thing. F to the power of 4, so when x equal to 4, have you noticed a pattern already? You notice one? What's the pattern? Cut it in half, keep cutting it in half. Okay, so we technically don't even need to know what this is. We could just go half of that, right, for the next one. Because you went 10, 5, half of that 2.5, half of that 1.25, and so forth. Yeah, you got it. So this is 1/16, like that, which is 0.625. Patterns, you did a lot of that in elementary. I don't know if your teachers did that, right? Math has lots of patterns, right? They want to see, they want you to observe. It's like, oh, wait a minute, I noticed something, right? There's something happening. So in this particular case, and in both of them, look at the very first point. This would be 0.02, right? Right? That's the first one. When x equals to 0, y is equal to 2. That's what we found. What about this one here? When x equals to 0, what did we get? 10. Do you notice those numbers show up somewhere? Notice that? You notice this? So we know something about that number. We know that that's going to be our y-intercept, right? That's our y-intercept when x equals to 0. I'm maybe it's just me that I'm excited. You don't seem too excited. You're thinking of Black Friday, right? Sales. That's what you're thinking. All right, that's okay. So okay, next, what's the other pattern we observe? And Ben was alluding to that, right? This goes up, right? We went times 3, and then we went from 6 to 18, which is also times 3, and the pattern continues, right? It's always going up by a factor of 3. And the 3, you should notice, where is that? It's way up here, right? You see that? The 3, right? Oh, my bad. I didn't use a highlighter. My bad. Why would he? Yeah. It's almost like Brazil. If you follow the World Cup, that's the team to follow. All right. Yeah, no. Don't talk about that. My buddies will never stop talking about that because I cheer for Brazil whenever Paraguay isn't in the World Cup. That's my team. Or Germany, one of the two. Yeah, I don't mind Germany. Yeah, I like their style. Okay, and now it's Canada in the mix. That's new. Half. You see that? That's gonna show up here. Times half. Times half. Times half. Times half. Let's talk about. So we talked about the pattern. What happens to the y values in this case? Are they going up or down? When there's a 3 there, this went up, so this is increasing. increasing. What happens when what's inside the bracket is less than 1? It's decreasing. I might be giving too much away, but I kind of just want to, right, make those connections and then move on, right? Because the next box is going to summarize what we just did here. Okay. So in general, when you have a function like this, y is equal to a times b to the power of x, I will warn you that some of the homework questions will be like this. I've seen it like this. Not a big deal, right? The exponent is inside the bracket with b, not a big deal. Same thing. We're doing the same thing, okay? A gives the y-intercept, right? 0a, right? So you know that's going to be part of your graph when you're graphing it. And b determines whether the graph is increasing or decreasing, okay? And so if b is greater than 1, right? If b is greater than 1, you have an increasing function. If b is between 0 and 1, it'll be decreasing. And you're like, what about negative? You can't, we won't do negatives, okay? B will either, too many B's there in that statement, but B will either be between 0 and 1, right? So it could be 0.0001 all the way to 0.99999, right? Like it could be anywhere in between there, or it could be greater than 1, in which case you have a increasing. And I don't like, I'm using Desmos and it doesn't put the arrows on there. And I like arrowheads there for that. So when you have this, this can always read a graph from left to right. So from left to right, you would have to say this is increasing, correct? So in this case, an example for this particular graph could be y is equal to, what do we know for sure a is going to be in this case? But a is my y-intercept, right? So that's going to be 3 for sure. No choice. That's going to be 3. And this is going to be bigger than 1. So you put in whatever you'd like. B is bigger than 1, right? I'm making it very close to 1 so you understand that, hey, as long as it's bigger than 1, it's going to be increasing. It's the rate will be slower, but it's going to be increasing. Okay. Over here, I didn't put this value in here. I'm thinking this is 3 as well, based on the graph. And so an example here would be y is equal to 3. What do you want to put in there? I don't know, 79 to the x, right? Something like that. You could do a fraction as long as it's less than 1. It's an example of that, right? So increasing, decreasing. However, I need to use Desmos to show you something. Even though it looks like it's going to cross or maybe touch the x-axis, in fact, it never does. So bear with me here. So this is an increasing function, and Desmos is really good at that. So see how it looks like it's touching? If you were to zoom in and then keep going, it will actually never touch. So here it looks like it's touching again. If we zoom in, it never touches it. Right? So it never crosses. It just gets infinitely small. It gets so small that it just keeps going, but because it goes to infinity, you can always slice something in half and half and half. You can keep slicing something in half indefinitely. When it comes to numbers, not apples, right? You cut apples at some point, you can't do it anymore, right? But when it comes to numbers, you can keep slicing and slicing and slicing. So it gets so small, it never touches, right? So that's something I need you to remember, right? That's going to be that I'm going to ask that of you at some point, right? Test that knowledge. So there we go. And so watch what happens to if I change the values of b, right? Notice what happens to the curve, right? As long as b is bigger than 1, it's increasing, and then it goes decreasing, right? And increasing, decreasing. So that's what happens to the graph when b is being changed. And what's going to happen if I change a? It really will just, notice I have it right here. It matches this value of a, right? Oops. Right, so a determines the y-intercept, and it effectively kind of raises the graph a little bit, right? It raises everything past the y-axis as well. Pretty cool, right? So there you have it. It's actually a very simple, like you'll never have any extravagant, like, you know, the cubic functions, they're sometimes scary looking. With this, you don't really get too scary. Some exceptions. Sometimes you will see some weird exponents, guys. You'll have like a decimal even in front of x. Type it in exactly the way it is. That's why we have graphing calculators, okay? All right, watch this. Notice in this course, we do not consider the case where a is negative, right? A will always be positive. You don't have to worry about a being negative. And I want you to add, okay, never crosses x-axis. That's one thing that's very, very particular about exponential. That's not the case for quadratics or cubic, right? They do cross. Exponentials never do, okay? And you know where this is used the most? Any ideas in real life where you would use exponential functions? Science? Did somebody say science? Yes. What in particular? Square rooting? We will do some of that, but this is used for population growth, money or population growth, or decay. You know how in chemistry things decay, right? Like things, the isotopes or whatever. I don't know much about chemistry. Sorry, it's been a while, but things decay over time, right? Radioactive material over time, it loses some, right? And so we'll look at that as well. Let's flip over to page 4. Characteristics of exponential functions. I tried to summarize it here. Watch this. For both increasing and decreasing functions, the following is true. Right? It doesn't matter if it's increasing or decreasing. The end behavior is always Q2 to Q1 or Q1 to Q2. It doesn't matter. But regardless of what's going to happen, either the graph goes like this or it goes like this, right? Those are your only two options. So this would be Q2 to Q1, and this still comes from Q2 to Q1, regardless of which way you're talking, right? X-intercepts, watch this. Exponential functions never cross the x-axis and therefore have no x-intercept. It does have a y-intercept, it doesn't have an x-intercept. Y-intercepts, exponential functions cross the y-axis and therefore have one y-intercept, and it's always going to be 0a, right? 0a is going to give you that y-intercept. What do you think the domain is going to be? It spans left to right, right? So that'll be all real numbers. I'm going to use set notation for that one. The range is a little different. It's a little different, but it can never touch the x-axis, so it's actually just greater than 0, not greater than or equal to. It's just greater, right? Like it never touches. Okay. I'm saying the same thing over and over again. I hope that sinks in. So now let's sketch. And I have to tell you, I don't have grids for all of these questions. Okay, so you're gonna have to, these ones are fairly simple to graph though. Okay, so looking at this, if I gave you that and I asked you to fill in this table, at first glance you don't see it, but I want to rewrite this. Or y is equal to, it's actually 1 times 3 to the x. You don't see that a is right in front of it, it's just 1, right? It's right in front of that, because some students think a right now is 3, and it's not. 3 is attached to the exponent, so it's actually 1. So what will this be, increasing or decreasing? Which number do we look at? We look at that one, right? It's increasing because b is greater than 1. The domain, super easy to do, but you still need to know how to do it. The range, you can copy paste domain and range for all the ones we're going to be doing. It's the same. That's kind of nice. The y-intercept is 0a, so we're going to go, this is 0, 1. And behavior, quadrant 2 to quadrant 1. And now for these ones, I will ask you to use your calculator, because once the numbers get really big, you don't want to be doing them by hand. Okay, so let's type this in. You go to your y1, you're entering an equation, so make sure plot 1 is turned off, right? You don't want that on out right now. You're gonna, sometimes they give you an error because of that. So you go here, and then you just go 3, you use the hat button for power, right? And then just type x. Right? Just make sure that the x is as an exponent, not next to it, or then you'll have a linear. And then let's go ahead and graph it. And my screen is not doing so well, so let's see here. Oh yeah, I see what. Dion, do you mind closing the first blind? I opened it, it's my bad. Let's do Zoom standard, right? Everybody Zoom standard, that way, right? Zoom 6 is Zoom standard. And there we have it. Okay, so we can use that. So let's go ahead and find when x is equal to -4, that means that we got to use what? Second trace value, x is equal to -4. And there it is. It's actually 0.012345. That's pretty cool. I didn't know that. That was just coincidence, right? So the y value is that. And on the other hand, if y is equal to 40, I need to go and type it into y2. And what's the problem with my current window? It's too small, right? I need to go to my window and turn y max to, I'm going to go 50. And I have a feeling that I'm going to have to increase the x max as well. I'm going to go 50 there as well. So go ahead and graph this, and there it is. It was a bit overkill for my x max. That's okay. It's because it's shooting up, right? So it's not expanding as quickly as it is going up, right? So second trace 5, enter, 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 and it is 3.36. 3.36. Let's tell ourselves how we got that. Second trace 1, and then we went x equal to -4. Here we went y2 is equal to 40, second trace 5. Okay. The keystrokes, normally yes, here I wouldn't care, like as long as you know how to get that. And sketch it, okay? So make sure arrowheads are everywhere. I gave you the basics, right? YX, this is not a word problem. So we're gonna make sure that the 0.1 is on there. Make sure it's a nice big fat dot right there. Without graphing this, guys, you know it's increasing, right? So I can just go here. Just make sure it doesn't touch the x-axis, whatever you do, right? So I'm gonna come over here and I kind of approach it, go a little higher. Once I get to the y-intercept, that's when I go up. I will tell you sometimes we will be a bit more specific with the points, but 0, 1 must, like that is a must to have that on there. So this is y is equal to 3 to the power of x, okay? I won't do them all, just so you know. I will just do a couple. The rest you can probably do for homework. Next, this is going to be a decreasing because b, right, is between 0 and 1. The domain, copy paste, right? We know that one. The range, copy paste. Y-intercept, 0, 6, and behavior, copy paste. And then when x equal to 50, what's y? We're going to figure that out. So I'm going to clear everything. I'm going to enter this, watch. So clear 6. I use brackets to the power of x. So I would encourage you to enter that. We know that it's decreasing. So we're expecting it to come from the left and down through the y-intercept. Hit graph. There it is. So when x is equal to 50, let's go ahead and find that. Second trace 1, x is equal to 50. It's a really, really small value. And I don't want you to put down 0. I don't want you to do that. So I will say this. It's 397 times 10 to the negative 6. That's what that is saying. It's saying e to the negative 6. Do not, whatever it takes, to not put 0 down in this particular case. I'll try to not make it that close to the x-axis. But anyway, so the next point here, if y is equal to 13.5, you hit that, and then you figure out the x value, and that is negative 2.82. The x value is negative 2.82 here. I will make an arrow here saying can't be 0, okay? Because it never touches. So here's our graph. Yeah, go ahead. Good luck. 0, 0, 6, right? 0, 6 must be on there. So what you do is just come down through it and then kind of inch your way towards the x-axis, but you never touch it. This is y is equal to 6 times 0.75 to the power of x. And I actually want to do word problems yet. I don't want to spend too much time on this no context scenario because it's not real, right? It's not what we're going to spend most of our time doing. So increasing, decreasing, the y-intercept, boom, right? So just be careful, kind of let your graph help you with that, and then we go, okay? So notice that a quadratic would do this. It would do this and then indicate that it's going back up. Exponential doesn't do that. Let's keep going. I will skip all of these. I will post the key to this if you want to give that a try. Before we go to the word problems, I will give you 2 minutes to match the equations at the top with the corresponding graph. It should not be that, it should not take you very long. So we're done or what? That's too, give me more time. What I'm gonna do, first of all, guys, I'm gonna tell myself, right, this is decreasing, right, because this is between 0 and 1. I scan, another decreasing right here. which means these two are increasing. It's like a doctor's note, right? Increasing. So right there, I narrow it down, right? And then I go to my graphs, and I notice that this is increasing, and this is increasing. This last one here. Let me zoom out a bit there. This is increasing. So that means that these two up here that are increasing must match these two here. Just go by the y-intercept. In this case, the y-intercept would be 0, 4. The y-intercept in this case is 0, 2. The y-intercept here is 0, 4. The y-intercept here is 0, 3, but I know that they're decreasing. I'll first take care of the increasing functions. There's a 0, 2 right here. So that means that this must match this one. You got that part? And that means that this one must match here, right? There's no other option, really. There. So those two are taken care of. And now I'm going to take care of my decreasing functions. One has an intercept of 3, the other one of 4. I notice that this one has the 4. So I'll just plot this one in here. And this one has a y-intercept of 3, which must be this one. This is where, in my opinion, if you can do this, you understand what's happening, right? You understand what's happening. You're like, boom, boom, boom. I know increasing, decreasing. I know when I look at it on the graph. I know when I look at the equation. I know the y-intercept. So then you know what you're doing, okay? Keep going. You're so fast. Word problems. This is the meat and potatoes, right? Now that we know how they behave, we're going to use those properties for our word problems. Recall that, right, we have this. A and B cannot be negative in this course. A is often the initial amount. Highlight that. A is the initial amount. It could be the initial population, the amount invested. Like, let's say you invest $1,000, so that's like the initial investment or initial amount. B tells you what's happening. What's happening to the initial amount? Increasing. You know what I'm talking about here, right? It cannot be less than 0. That's the typo number 1 right there. I think I was just assuming you would know, but really it's always this, it's always that. It cannot be less than 0. It cannot have negatives. And I think because I set it up here, I didn't worry about this, but let's just be consistent. X will often be time, right? It'll be days, months, years, hours, whatever the question, minutes, it could be seconds, right? Just look at the question. This is quite often used in relation to time. You should always ask, is the population increasing or decreasing? Is the investment increasing or decreasing? To determine B, read the question. It will be less than or greater than 1. If the question mentions a decrease of 5%, the equation would be, watch this. I'm going to skip that part. I'm going to skip this because I have more down there. Okay, skip for now. It's going to get better if I just skip to these ones here. I'm looking at my time. Write the following equations that would model each scenario. You invest 6,500. This is the initial amount. And that is going to be, what's that going to be? What letter in the equation? That's going to be A, yes. Your investment earns 2.5% annually per year. If something earns, you first need to say earns. What's 2.5% as a decimal? 0.25? That's 25%. 0.025. Okay. Earns 0.025. Earning means it grows, right? Wouldn't you say if something earns, it's growing? So that tells me that B has to be greater than 1, correct? So what you do is B is actually going to be 1 plus 0.025, which means that B is 1.025. And per year, that's X, right? Time per year. So the equation, you ready for this? Y is equal to 6,500 times 1.025 to the power of X. Does that make sense what I just did there? It's too much. You can handle it. I know you. I know most of you since grade 11. I know you can handle this, right? So we start with 6,500 and then our investment is going to go up every year by 2.5%, right? It's going to keep going. So that's everything here should jive with the question. Let's keep going. A small town has a population of 578. That is A, initial population. Watch this. There's a decrease. People are moving away, right? Or nobody's moving in. People are just dying off, right? Oh, that sounds harsh. Sorry. But we all die at some point, right? 100% chance of that happening. Decrease of 12.5%. So what does that tell me? Decrease, let's figure out, this is 0.125, right? If you divide that by 100, you get that. Decrease is telling you that B is going to be between 0 and 1. Soon you're not going to worry about that. You're not going to do this very soon. You're just going to jump right into what I'm doing next. B is going to be, watch this, 1 minus 0.125. That you need to understand. You're going to go 1 minus. And what is 1 minus that? It's going to be 87. I want to make sure I don't get this wrong on live television here. 0.875. B is 0.875, which is still a decrease. It's decreasing by this much every year, which means, are you ready for this? That you have this much left every year. You understand that? If you're losing 20% every year, that means that you have 80% still remaining. So that's how you have to see this. All right, so are you ready for the equation? Oh, each year. So that's going to be, you can make that T if you want. We're going to call that X for now. So the equation would be Y is equal to 578 people. And because I'm losing 12.5% every year, that means that I have this much left. And there you go. That's the equation right there. One last one. The number of bacteria in a petri dish is 25,000. It triples every hour. This is A, this is B, and this would be my X, right? Every hour, time is in hours in this case. So you would go Y is equal to, it triples, so we start with 25,000. Yes, you just put that in. Triples, 3. Doubles, 2. Quadruples, you just put a 4 in there, right? So increasing functions are easier to come up with than decreasing because of this step, okay? Important step, right? This is very important. And if you miss that, so a lot of students put the 0.125 in here. That means that you're losing 87.5 every year, actually, if you get that wrong, okay? Okay, I think I'm going to stop there. Let me just see what I can assign you a little bit to practice. How about nothing, right? I want you to try page 9. I know I haven't done that, but I'm still going to assign it because you know a lot about functions and how to use your calculator. So this is homework right here. Page, hold on. I assigned, you know, the graphs we skipped. Let me just go and get that page for you. Page 5 and page 9 in this textbook. That's all. That's all. Nice and easy.